Good morning, all of you. Welcome to the J in the rank zone. So far, we have done complete explanation part of the coordination compounds. Now, in this lecture, we are going to do the questions based on entire chapter. So, more 2 lectures we'll do, and we'll finish up this topic. So, let us see the questions based on this topic. Especially these questions are prepared for NEET students, and even JE means also it is useful. So, these questions are useful for JE means and NEET students. So please listen carefully and try to understand. If you could solve these questions, this is more than enough for this chapter. So let us start now. Yes. Question number 1. The oxidation number of nickel in K2 NiCN taken 4 times is. So how to find out this? So we already know potassium is +1 in all its oxygen states. So the one which you are going to find, we'll keep it as X. So we'll take 1 into 2, that is 2 plus X. And cyanide is radical, it is -1 charge. So plus -1 into 4. -1 into 4 is equal to 0 because sum of all the oxygen states is equal to 0. Sum of all the oxygen states of a compound is always equal to 0. If there is charge, it is equal to charge. This already we know. So 2 plus X minus 4 is equal to 0 implies 2 plus X is equal to 4 implies X is equal to 2 plus 2. So answer is +2. So option B. Let us see now. So option B, like these questions you may expect, simple questions. So cyanide is radical and we'll call it as, what is the name of this compound? This compound is tetracyano, potassium tetracyano nickelate 2. Potassium tetracyano nickelate 2 because this is anion complex. This is an anion complex. So we can even, by seeing the question also, you can even know the, if you practice by naming the coordination compounds, it will be useful for nomenclature. So that's why it is very important. So answer is +2 here, as we already solved it. Next question, we'll move to next question now. Which of the following is example for tetradentate ligand? Tetradentate ligand means it can donate 4 electron pairs. How many electron pairs? Tetradentate means monodentate, bidentate, tridentate, tetradentate. So it can donate 4 electron pairs. 4 electron pairs. So En is the bidentate ligand, since already you know this is Pn and this is triene and this is diene. So what is the answer? It could be En means ethene diamine. Ethene diamine. Pn is phenylamine and triene, that is 3 molecules of En. So answer is C. This is tetradentate ligand because it is triene. Triene means tri in bis tris, like that we have triene. More than one bidentate ligand is there, we'll call it as bis, tris, and tetrakis. So En is bidentate ligand and is triene. So triene is nothing but tri ethane 1,2 diamine. Tri ethane 1,2 diamine. Tri ethane 1,2 diamine. So this is the answer. It is nothing but tetradentate ligand. I hope you understood clearly. Next question. We'll move to next question. Coordination number of cobalt in COCl2En taken twice plus is. What is coordination number? The number of ligands attached to the central metal atom. The number of ligands attached to central metal atom is called coordination number. So this is called coordination number. Even if you see the questions, you can understand the entire concept of the chapter. We have made so many questions, almost 100 questions, and even in the lectures also we have solved so many questions. So with these questions, easily you can crack any entrance exam from this chapter. Easily you can solve. Now, since it has chlorine, 2 chlorines, and En2 is nothing but bidentate. So 2 into 2, 4. So we'll take it as 2 plus 4 is equal to 6. Since En is bidentate. Ethene diamine is bidentate. So we'll call it as 1 is 2. So 2 times of En. So it is 2 plus 2, that is 4. So 2 plus 4 is equal to 6. So the coordination number of this answer is 6. This compound is 6. Let us check the answer. So it is 6. In this way, we'll calculate coordination number. Next question. So please note down in your classwork the number of ligands attached to the central metal atom is called its coordination number. So coordination number for monodentate ligands will keep as this number. For bidentates into 2. So bidentate here ethane diamine is 1 comma 2 diamine is bidentate. So it is how many 2 molecules are there? So 2. So since it is 2 and 2 into 2 is 4. So 2 plus 4 is equal to 6. So this clears your explanation. We'll proceed to the next question. The hypothetical complex triamine diaqua colloido cobalt 2 chloride can be represented as. So this is based on nomenclature question. So the answer it could be hypothetical complex triamine. So amine is 3 and so it should have NH3 taken twice, taken thrice triamine, and diaqua means H2O taken twice. Chlorido means cobalt Cl, and here we have cobalt. So this is the question, this is the answer. Chlorido they have given. So chlorido means only one Cl should be there, and CO, Cl, NH3 taken this, H2O taken, and cobalt 2 chloride. Outside also cobalt is +2 state, cobalt 2 chloride. So this is inside the bracket because chlorido is given inside the bracket, so it should be. And outside we have again chlorine. Chlorido, cobalt 2 chloride. Outside number of chlorines cannot be. It can be 2, 1 or 3. It should be the same. So answer for this question is easily you can guess it now. So cobalt, this is cobalt, and very important is oxygen state of cobalt should be +2. +2 means this should be, the cobalt should be +2 means outside you have only one chlorine because these two chlorines are ligands. So very important. So the Cl2 will not come. Here we'll get only one Cl. Why we'll get only one Cl? Because cobalt is +2 state. +2 state means this is 1 minus 1, this is -1. And these two are neutral ligands. Since these two are neutral ligands, amine and H2 are neutral ligands. So they will not contribute anything. So neutral ligands. So automatically Cl, one will be inside, one will be outside. So the answer you can guess it now. It is option C. What option it is? It is option C because cobalt 2 chloride. 2 is there. Suppose if they have given 3 chloride, so it could be first option. If they have given cobalt 4 chloride, cobalt 3 chloride only maximum. So it should be first. One chlorido is there, very important. Chlorido is kept inside the complex unit, that is coordination entity. So answer is for this option cobalt, triamine, diaqua, chlorido, cobalt 2 chloride. 2 means here these two Cls only will form donors, ligands. So this is -1, this is -1, this is -1, this is -1. So definitely this should be +2. So cobalt 2 chloride. I hope you understood this answer. Next question. Neutral ligands will never donate any electron pair. The IUPAC name of NiNH3 taken 4 times NiCl4 is. So this is nickel, and here what is the oxygen state of nickel in this, and in this also we have to check. So let us see now. This is again anyway tetraamine, and this is tetraamine. So tetrachloro nickel 2, tetraamine nickel 2. Tetraamine nickel 2, tetrachloro nickel 2, tetraamine nickel 2, tetrachloro nickelate 2, and finally tetrachloro nickel 2 and tetraamine nickelate 2. So we have to see the answer now. Let us see now. So answer is tetraamine nickel 2 because tetraamine in this the oxygen state of nickel is +2, and here also it is +2. Total it is 4. So it is 2 and 2 is distributed. So tetrachloro nickel 2. So answer is B option. Like this you have to check, very important. Even though it has neutral ligand, definitely this is not 0. So total it is 4. So total it is 4 means definitely one nickel should be +2 and another nickel should be +2. So you will get the answer like this. I hope it is clear now. Next question. We'll move to next question. So in this session and the next session also we'll discuss only questions based in coordination chemistry. The pair of compounds in which both the metals are in the highest possible oxidation state is highest possible oxidation state. So what is the oxidation state of iron here? It is +3. What is the oxidation state of cobalt here? It is +3 because 3 minus is given. So x minus 6 is equal to -3. So implies x is equal to +3. So CrO2Cl2, CrO2Cl2, the oxidation state of chlorine is +6 and here it is +7 manganese. And TiO3 it is +6 and it is +4. And cobalt Cn taken 6 3 minus, this is +3 and this should be +6. So the pair of the compounds in which both the metals are in the highest possible oxidation state, we have chromium and manganate ion. So definitely this should be the answer. So let us see the answer now. It is option B. It is what? Option B. Because in this, the oxidation state of chromium is +6 because 2 oxygen means -2 into 2, -4, and 2 chlorine means -1 into 2, -6. So if this total becomes -6 means definitely this should become +6 and this will become Mn x minus 8 is equal to -1. So implies x is equal to +7. So manganese is in highest oxidation state, chromium is also highest oxidation state. So beyond this, chromium cannot exhibit +7 and manganese cannot exhibit +8. So that's why the pair of the compounds in which both the metals are in the highest possible oxidation state. Highest possible oxidation state is chromium in +6 and manganese is +7. So answer is option B. I hope it is clear. Next question. We'll move on to next question now. The type of isomerism present in nitropentamine chromium 3 chloride is nitropentamine chromium 3 chloride. Chromium 3 chloride means chromium is in +3 oxidation state and nitro NO2 pentamine, it is nothing but pentamine chromium 3 chloride. So first we'll write the formula of this compound. So chromium it is Cr, pentamine it is NH3 taken 5 times, pentamine, and nitro means NO2 and cobalt 3 chloride. Since these two are neutral, these two becomes neutral ligands. So definitely this should be Cl3. So what type of isomerism it can be? So the donor atom can be nitrogen or even chlorine also. So it can be optical, linkage, coordination, polymerization. So let us check the answer now. So what it could be, you can guess it easily. It is linkage because as I told you, it can link to nitrogen as well as chlorine also. So it is nothing but linkage isomerism. So the same you can write it as same compound. If nitrogen is giving, so Cr NH3 taken 5 times, Cl3 inside and NO2 outside we can write. So this could be again Cl2 inside. This is Cl2 only because nitrogen will give 1. So this could be the donor atom can be nitrogen dioxide also, or the donor atom can be chlorine. So that's why it is called as linkage isomerism. It is called what? Linkage isomerism. So you should be thorough with all the topics. Next question. Which of the following will show optical isomerism? Very, very important. Which will show optical isomerism? First condition is it should contain at least one bidentate ligand. It should contain at least one bidentate ligand. So bidentate ligand means it should have 2 electron pairs. It can donate bidentate ligand. First condition. So this is amine. Amine is nothing but it is monodentate ligand and is neutral. Chlorine is monodentate. Oxalate ion. This is C2O4 is there. C2O4 is called oxalate ion. So oxalate, it is nothing but C2O4 2 minus. 2 minus means it is donating 2 electron pairs. So oxalate is bidentate ligand. So definitely the answer could be oxalate because cyanide is also monodentate. So answer is C. Without fail, we can say it is option C. This can produce optical isomerism. So it is not B. It is given wrong. It is C. Please note it down. This should be definitely C because chromium C2O4 3 minus. So in the form of M En taken thrice 3 minus. Definitely this should be En means bidentate. So C2O4 3 minus is C2O4 2 minus. So C2O4 2 minus is oxalate. It is bidentate ligand. should contain at least one bidentate ligand to exhibit optical isomerism. Definitely this is the answer, maybe printing mistake. So answer is C, this is not B. Please check it out. Next question, we'll move on to next question. Which kind of isomerism is exhibited by complex CONH3 taken 4 times Br2Cl? Ma4B2, Ma4B2. So this type of isomerism. So it could be bromine can go outside and chlorine can come inside. So it should be geometrical and ionization, geometrical and optical. Anyway, optical is ruled out. Optical and ionization is ruled out. Either geometrical, either option A and option B. Definitely it will go geometrical isomerism because these are the form Ma4B2. Ma4B2 molecule will exhibit geometrical isomerism, geometrical isomerism. And moreover, it is exhibiting ionization because chlorine can come inside, bromine can go outside. So this can form ionization isomerism because it can give chlorine ion as well as bromine ion. So I think this should be option A. Option A. Optical there is no chance because optical for producing optical isomerism, it should have at least one bidentate ligand. So this also option somewhere it is given wrong. This is option A. So please note down option A. Next question. CrCO taken extremes follows EAN rule. Find the value of X. EAN rule. What is EAN rule? Effective atomic number. Effective atomic number means effective atomic number. How to find effective atomic number of cobalt? Z minus X plus 2 into coordination number. What is X? Number of ligands and coordination number. So sorry, X is nothing but what? Z is equal to atomic number. So atomic number of chromium is 24 minus oxygen state of chromium it should be. So let us see it is plus 6 because chromium can go up to plus 6 plus 2 into coordination number, 2 into coordination number. Let us take X is equal to 6. Let us find the value of X. So it is 24 minus 6, 18. 18 plus 12, 30. 18 plus 12, 30. So definitely X is not 6. So it could be 4. Like that you have to see the probabilities. So how to find EAN? That is Z minus X plus 2 into coordination number. So let us see now. It should have EN means they should have inert gas element. It should have inert gas element means 36 should be the answer. 36 should be the. So chromium plus 2 if you take 24 minus 2 is 22. 22 plus 12, 34. So it should not be answer. Now let us see. It is 6. How it is 6? Let us see now. So 24 minus, let us consider oxygen state of chromium is plus 2 here. So 24 minus 2 plus 2 into 6 because oxygen state of central metal atom is X. So it is minus 2. So 24 minus 2 into 6 is equal to 24, 22 plus this is 12. So that is should be 34, but it should come 36. So definitely oxygen state of chromium should be 4. So 24 minus 4, 20. So it should be 1. So answer is plus 6. Answer is what? Plus 6. Next question. How many of the following follow EAN rule? EAN rule means effective atomic number should be the effective atomic number of central atom. Effective atomic number of central atom should be equal to nearest inert gas. Effective atomic number of central atom should be equal to nearest inert gas element. Nearest inert gas element. So that is the condition. And how to find effective atomic number? As I told you, effective atomic number is equal to Z minus X plus 2 into coordination number. Coordination number means number of ligands. Number of ligands. So here, for example, for iron, if you try, what is the atomic number of iron? 26 minus what is the oxygen state of iron? It is plus 2. So oxygen state of iron is 2 plus 2 into 6 because it contains 6 cyanides. So it is equal to 26 minus 2 is 24. 24 plus 12, that is equal to 36. 36 is krypton. krypton atomic number is 36. So definitely option A is first option is correct. Let us see second. So what is the oxygen state of iron here? Plus 3. So it will come 26 minus 3. So it is 23 plus 12, 35. It will not come. Next, cobalt oxygen state is plus 6. Plus 3, sorry. Here it is plus 3. So plus 3 means here cobalt 3 and here effective atomic coordination number is 6. So like that you can check. So En is equal to what is the atomic number of cobalt? Cobalt it is equal to iron cobalt nickel. So it is 27 minus 3 plus 2 into 6. It is equal to how much? 27 minus 6 24. 24 plus 12 36. So even C also can form because it is nearest in gas krypton atomic number. So even C also can form. And even nickel, the oxygen state is 0. So 28 minus 0 plus 2 into 4, that is 8. 28 plus 8, 36. So even this also we can take into consideration. So right answer, we'll check now. It is option B only they have given. How many follow EN rule? EN rule means they should have. Will not follow. Actually, the question might be changed because we have got A, C, D correct options because in all the three cases we got the effective atomic number of nickel in this case also equal to 36, which is equal to chromium. So how many of the following will not follow? Will not follow EN rule. Not follow. That should be not. Maybe the question is given wrong because A, C, D will follow EN rule because after calculating we got 36, 36, 36. Definitely this should be the right answer. So option is B. Not follow means option is B. Not follow. Change the question. Next question. Ligands with which linkage isomerism is possible. Linkage isomerism possible means it should be ambidentate ligands. What is that? Ambidentate ligands. To exhibit linkage isomerism, linkage isomerism, the ligand should be ambidentate ligands. Ambidentate ligands should be present. So what are ambidentate ligands? Which can attack, which can donate electron pairs from two atoms. So I think in this case NO2 minus, we have NO2 minus, NO2 minus. The donation is from nitrogen, or you can write the same thing as ONO minus. The donation is from oxygen. So it has correct. This is ambidentate ligand. Next CN minus, CN also donation is from carbon and donation is from NC, donation is from nitrogen. So this also ambidentate. And finally SCN also donation is from sulfur. Second case it is NCS, donation is from nitrogen. So this is also ambidentate ligand. So answer is all. Answer is what? It is all. All of them can possess linkage isomerism because to exhibit linkage isomerism, ambidentate ligand should be present. So ambidentate ligands means NO2 minus, CN minus, SCN minus. All are ambidentate. So if it is the donation to nitrogen, it is we'll call it as nitrito N. If donation is from oxygen, we'll call it as nitrito O. If donation is from carbon, we'll call it as cyano. If donation is from nitrogen, we'll call it as isocyano. If donation is from sulfur, we'll call it thiocyano. If donation is from nitrogen, we'll call isothiocyanol. So in all these cases, they can donate, the ligands can donate electron pairs from two atoms. First case from nitrogen, second case from oxygen, third case from carbon, fourth case from nitrogen, fifth case from sulfur, sixth case from nitrogen. So I think the option is 100%, it is all. So let us see, it is correct only. So answer is all. So this question is very, very important. Like these questions are most important. Next question. With what is wrong about following pair of compounds? Wrong statement. So COH2O taken 6 times and COH2O taken 3 times, Cl3 dot H2O. So it is nothing but they have hydrogen isomers. It is correct only. They have different colors. Their 0.1 molarity aqueous solutions have same molar conductivity and they have different IUPAC name. So this should be, the answer is C because first statement is correct, hydrogen isomerism because water molecule is changing. Second statement, they have different colors because of the oxygen state of cobalt. And third statement, Their 0.1 mole aqueous solution have same molar conductivity. It is wrong because in this chlorine is not present, in this chlorine is present. So option is C. They have different IUPAC names. Obviously, they have different IUPAC names. So definitely the answer is C. So this is very easy question, which is wrong. So wrong statement is C. Next question. Geometrical isomerism is observed in, it's very simple question. We know geometrical isomerism is observed only in square planar complex as well as octahedral. Square planar complex and octahedral complexes only. Geometrical isomerism is observed only in square planar and octahedral complexes only. It is not observed in tetrahedral. So answer it should be here B. Remaining all different. So answer it should be B. Geometrical isomerism observed in square planar and few octahedral complexes. So answer is definitely B. Very, very important. Next question. K4FeCN taken 6 is a double salt, complex compound, neutral molecule, none of this. So definitely it is a complex compound. So answer is B because K4FeCN taken 6 times is a complex compound. The oxygen state of platinum in the complex P2C2H4, this is diethyl Cl3 minus is. This is neutral ligand Cl3 minus is. So definitely this should be how to calculate oxygen state. X, this should be taken as X, and C2H4 is neutral ligand, and Cl3 minus 1 into 3 is equal to minus 1 is equal to minus 1. From that easily you can find out X. So answer is plus 2 because this is neutral ligand. This is neutral ligand. So no need to consider this since it is neutral ligand. Ethene is neutral ligand. So definitely we have X plus minus 1 into 3 is equal to minus 1 because of total charge. So X is equal to minus 1 plus 3. So implies X is equal to plus 2. In this way you have to calculate oxidation state. In this way you have to calculate oxidation state. Next question. All these questions are very important for NEET level. The effective atomic number of chromium in CrNH3 taken 6 times Cl3 outside. Outside will not consider, only with coordination entity. This one will consider. And the oxygen state of chromium is plus 3 here because outside is Cl3. So this is neutral ligand. So let us see the coordination number is equal to effective atomic number En is equal to the, what is the formula? En is equal to Z minus X plus 2 into coordination number. So what is Z? Atomic number of chromium is 24, as we already know, minus 3 because it is 3. Oxygen state of central metal atom, X is called what? Oxygen state of central metal atom, it is minus 3 plus 2 into, it is not minus, actually it is plus 3, but the formula wise it is minus. So we have kept minus. Plus 2 into coordination number, so number of ligands attached to central metal atom, not outside, only inside we have to consider, so it is 6. So it is 24 minus 3. It is equal to 23 plus 12. 23 plus 12, this should be answer 35. So answer is first option. So in this way, we will calculate effective atomic number. But they have given third option, which is quite wrong because the oxygen state of chlorine is minus 3. This should be plus 3 definitely. So this is 35 only because 24 is the atomic number of chromium. Atomic number of chromium is 24, it is right. So minus 3, oxygen state of central metal atom is minus 3 plus 2 into 6. Minus 3, why? Because it is 3 chlorines are outside. So definitely this should be plus 3. Chlorine is in plus 3 state and Cl3 is in minus 3 state. So 2 into 6, that is 35 only, it is not 33. So please do it. This is wrong. Option A is the right option. So you can see effective atomic number. The formula is correct only. Next, cobalt NH3 taken 6 times SO4Br and cobalt NH3 taken into Br SO4 are pair of dash isomers. Easily we can say one is sulfate is inside and there is bromine is inside. So definitely this is called ionization isomerism because ionization isomerism Br minus SO4 2 minus. So definitely it is ionization isomerism. Just you can see definition of ionization isomerism, you can understand it clearly. Next question. So like these questions are important in the examination. Ethylene diamine is example of ethylene diamine is En. En is nothing but what? It is a bidentate ligand. So option B, straight question it is option B. Yes. So answer is B. Next, the number of ions per mole of the complex COCl3.5NH3 in aqueous solution will be the number of ions per mole of the complex COCl3.5NH3 in aqueous solution will be. So how many ions it can form? Maximum 3, because only 3Cl. This is neutral ligand. Since here ammonia is neutral ligand, ammonia is neutral ligand, it has no contribution. So automatically only 3 chlorines are there. So it can ionize 3. So number of ions per mole of the complex means it can give only 3. Because 3Cl minus it will form. How many ions it will form? 3Cl minus. Next question. What is the coordination number of chromium in K3CrOX3? OX means what? Oxalate ion. OX is what? It is oxalate ion. Oxalate ion. Oxalate ion is, it is nothing but C2O4 2 minus. It is bidentate ligand, so its coordination number is becomes 6. So what is the coordination number of chromium? Coordination number is, since bidentate ligands, oxalate ion is bidentate, and bidentate ligands are present. How many? 3 are there. So 3 2 is 6. So answer would be A. Answer is what? It is A. Definitely it is A. What is OX? OX is called oxalate ion C2O4 2 minus. It is bidentate ligand. And bidentate means 2 electron pairs. 2 into 3, it is becoming 6. Next question. What is the oxidation state of ion in K4FeCN taken 6 times? It is very simple question. So potassium, it is +4. +4 minus X minus 6 is equal to 0, because cyanide is, each one is -1. -1 into 6, it is -6. So X is equal to +2. So it is +2. Option D. Yes, it is option D. Next question. The effective atomic number of cobalt in the complex ion COEN taken twice Cl2 plus is. First, we'll find oxidation state of metal. To find effective atomic number is equal to, what is the formula? Z, that is atomic number, minus X, that is oxidation state of central metal atom, plus 2 into coordination number. So here coordination number becomes 6, because this is bidentate. So 2 into 2, 4, 4 plus 2, 6. And here what is the oxidation state of cobalt? Let us see now. This is X, this is neutral, minus 2 is equal to -1. So implies X is equal to +1. X is equal to how much? It is +1, it should be, because, sorry, it is +1. 1 minus 2, it should be +3, sorry, because X is, I'll write it clearly again. So let us think oxidation state of cobalt is X plus En is 0, because it is neutral ligand, plus -1 into 2, 2 chlorines are there. Sum of all the oxidation state is equal to charge. So total charge is equal to +1. So X should be +3. X should be how much? It is +3. So what is the oxidation state, atomic number of cobalt? Cobalt is 27. So 27 En is equal to 27 minus oxidation state of central metal atom, it is +3. So it is 3 plus 2 into coordination number. This is 2 into 2, 4, 4 plus 2, 6. 2 into 6, 12. So 27 minus 3 is 24 plus 12, 36. So this should be answer 36 is equal to krypton. So it is following EN rule. So answer is 36. Let us check the answer now. Option B. So definitely it is option B. So in the previous classes, we have done the same thing, but somewhere they have given wrong option in typing mistake. So I have corrected it. So you also do the same thing. So effective atomic number is equal to 27 minus 3 plus 2 into 6. So 24 plus 12 is equal to 36. In this way, you'll find effective atomic number. This formula is important. What is X? What is X here? X is equal to oxidation state of central metal atom. Oxidation state of central metal atom. So X is called oxygen state of central metal atom. So with this we have done. So it is given plus 3. So we have to formula it is minus. So we have to keep minus. So minus 3 plus 2 into 6 is equal to krypton. In this way you have to calculate. So these type of questions are very important for NEET and JEE means. Next question. Geometrical isomerism is found in coordination compounds having coordination number minimum. Actually, we know the square planar complex. Geometrical isomerism is possible only in square planar complex and even some octahedral complex also. But majority geometrical isomerism is formed in square planar complex. Square planar complex means the coordination number should be 4. Coordination number should be 4. It is not tetrahedral and even octahedral complex also, since they have given geometrical isomerism is formed in square planar complex as well as octahedral. Octahedral coordination number is equal to 6. But they have given coordination number 4 with tetrahedral. Tetrahedral it will not form. So option is 6. Quantity they have given tetrahedral. So it is wrong because tetrahedral it will not form at all. Only square planar complex. In that square planar complex, coordination number is equal to 4. If they are given only 4 without tetrahedral, that is the right answer. Even this also C and D will be the right answer. Since they have given 4 with tetrahedral, so it is not the right answer. So answer is 6. Very, very important. Next question. Metal which is present in hemoglobin is also present in, the metal which is present in hemoglobin is iron. So iron is also present in tolerance reagent, vitamin B12, cisplatin, and sodium nitroprusside. Sodium nitroprusside, it is used for nothing but it is called Lassane's test. What is it is called? Lassane test. So cisplatin, cis isomer of platinum chloride. So the answer could be, what is sodium nitroprusside? It's Lassane's test. In that sodium is replaced with iodine. Sorry, iron is also present. So definitely the answer is D. Very, very important. Sodium nitroprusside. Which of the following has the highest molar conductivity under similar conditions? Molar conductivity is number of ions they dissociate. More the number of ions, more is the molar conductivity. So diamine chloroplatinum 2. So chloroplatinum 2 means it is only one ion, Cl minus. Tetraamine dichloride, this is 2 Cl minus, 3 chloride. Even chloride is also outside. So this should be Cl2. So number of ions. I'll just write the formula, just basic formula, right? So platinum diamine, first option I'm writing here, platinum diamine chloroplatinum. So chloroplatinum 2. So this should be Cl2, not Cl2, only Cl. And here it should be, plus should be there. Next, tetraamine dichlorocobalt 2 chloride. Tetraamine means cobalt is a central metal atom. Tetraamine means NH3 taken 4 times. And dichloro means definitely it should be inside the complex and outside it should be one more chloride. So chloride is given, so it should be. So number of ions in this is 1, in this is 3 because 3 chlorides are present. And in this potassium hexacyanoferrate 2, potassium hexacyano K4FeCN taken 6 times, ferrate 2 ion. So this becomes 4 plus 1. So number of ions is equal to 5 because it becomes 4K plus FeCN taken 6 times minus 1. So 4 plus 1, it is equal to 5. Next, hexa aqua chromium 3 chloride. Chromium 3 chloride means aqua. Hexa aqua means Cr H2O taken 6 times. Chromium 3 chloride means it could be chlorine outside 3 and inside it is 1. So this will produce only 3 Cl minus. So 3 5 3 5 1 3. So first one it will produce how many ions? 1. Second one it will produce how many ions? Tetraamine dichloro, it is 3. Third one it is producing 5 and fourth one it is producing only 3. So answer is definitely C. Because more the number of ions, more is the molar conductivity. More the number of ions, more the number of ions, highest is the molar conductivity. Highest is its molar conductivity because 1 mole can produce 5 ions. molar conductivity. So this is the answer. Let us check the answer now. You can write in your classwork clearly, as I told you, potassium hexacyanoferrate 2. Ferrate 2 means ion in oxygen state is +2. So this is the formula. And for this, it can produce 4K plus 1 mole of 1 ion of FeCN taken 6 minus. So this is nothing but 4 plus 1, it is equal to 5. So please note it down. More the number of ions, highest is its molar conductivity. If they ask about molar conductivity, definitely you have to check the number of ions produced by that complex compound. If the number of ions is more for a given complex compound, definitely that complex compound will have highest molar conductivity. I hope it is clear. Next question. So we have discussed already 25 questions from the basic. Next, we'll see 27th question. If excess of silver nitrate solution is added to 100 ml of 0.024 molarity solution of dichlorobis ethylene diamine. Ethylene diamine means bis means 2. Cobalt trichloride. How many moles of AgCl will be precipitated? Very, very simple. Just you have to see the number of ions. With that, you have to multiply with this, because in this case, N1V1 is equal to, M1V1 is equal to M2V2. We need to find the number of ions. So let us check the answer now. So first I'll write the formula of this compound. What is the formula? Dichloroethylene bis ethylene diamine cobalt trichloride. Means what it is the formula here? Cobalt dichloro bis ethylene diamine, that is En taken twice. Outside cobalt trichloride means it is outside one, because cobalt is plus this state. So this is neutral ligand, so this should be this. So 3 into 0.024. 3 into 0.024, that is M1V1 is equal to M2V2. So V1 is equal to 100 ml. How many moles of AgCl would be precipitated? How many moles? Means they are asking number of moles. So if you find out the molarity, that is volume, easily you can find number of moles, because V is proportional to number of moles. So this should be 100 into 0.024 is equal to X into 0.024. So X is equal to 0.024 by 100, and the number of ions is 3. So 3 moles. So that is equal to, you'll get the answer C, 0.024, 0.0024, because it is producing 3 ions. This type of questions are important. You can just check it out. Next question. So we have completed this session now. And now we'll discuss some more questions based on this in the next session. So with this, I'm ending this session. Because we have completed one important, all the 27 questions in this lecture. In the next session, we'll do some more other questions. So please do that. Thank you all.